Hello, good afternoon. Thank you very much for joining me today. I'm giving a presentation on printed electronics for smart textiles. I see quite some familiar faces. Front row, we have Mano from Fashion Nerd. Thanks for being here. And I see some people that have already visited our booth next door. But even for the people that I don't recognize, I already know that you are my kind of people. Because you've taken the time to come here, to come to the Keyhouse. You're definitely curious people, I'm sure. You're looking for innovations, probably, sustainability. And you're looking, probably, for knowledge, to learn something. That's why you're sitting here and taking the time off from the actual trade fair. So, big applause for you. So my name is Pauline van Dongen. I'm a fashion designer, and I have about 9 years' experience working in wearable technology. So I started specializing in technology in 2010 without being trained in it. So a lot of the things that I will tell you today are really things that I've learned through practice, through working very interdisciplinary with many different industries and many different people. At the moment, I'm working at Holcenter. Holcenter is a research and development center in the Netherlands, based in Eindhoven, where we develop printed electronics. And this week at Munich Fabric Star, we also have our own pop-up lab right next door, which you're welcome to visit after my talk, where we actually show you what it means to integrate electronics into textiles and how we can integrate them in a way that's also implementable in industry. How can we mass manufacture? How can we scale these technologies? So what I'm going to tell you in the next hour or so is, of course, I'll take you through the process of printed electronics. I'll tell you about the materials that we're using, the processes that we're using, and I'll give you some example cases of the products that we've developed and the clients that we work for. And then for my own experience, I will tell you a little bit about the challenges, the do's and the don'ts, and what is up next for printed electronics. So, maybe you're starting a new collection, you're starting a new project, you have a blank slate in front of you, and you're thinking, what textile should I use? What should I start with? And why should you even look at smart textiles? Maybe that's a good question to start with. Especially for those who have no experience working in smart textiles, it might be a bit of a leap forward. So, well, we're at the textile trade fair. There are a lot of options in terms of textiles, maybe even too many. And what can you choose to really differentiate? What makes your design unique in terms of the textiles that you choose? And that's why I think smart textiles can be really interesting, because they allow a new kind of relationship, a new kind of experience with the person wearing this textile. So, if you look at the amount of textiles and garments that are being produced, I think we're really looking for new values, new ways to communicate intimately with the body. And this is where the potential of smart textiles really come in. Because basically, when you make a textile smart, when you give it a certain degree of intelligence, it gains a certain agency. It is able to say something to you, maybe about you. Maybe it can have a dialogue with you. So I'm not only talking about tracking technologies, I'm not only talking about having a measure of your heart rate. This goes much further beyond that, and I'll tell you later how we do that. And I wanted to start off with a bit of a bold statement. I was recently interviewed by Muchanetta and Mano from Fashion Nerd, and this was one of the quotes that they put up in the article. And maybe it's a bit, maybe it's not done at a textile fair, at a fashion design fair to say something like this, but I think it's important to mention from the start. Because what I run into a lot when I work together with textile companies, with fashion brands, is that we're not really familiar in the fashion industry to invest and to dedicate ourselves to research and development. Of course, there are exceptions, and there are a lot of textile companies or even fashion brands who are investing in it, so don't get me wrong. But typically, they're not really familiar with it. They rather outsource it to other companies. But I think to really create a useful and an engaging product that can integrate with our daily lives, we really have to work hands-on. And the companies that want to bring these products to the market should really be involved very closely in that product, in that process, and work together with a lot of different parties to understand what it takes to create such a product. And then you will learn as you go, like I did myself. So printed electronics, what is it? We had a lot of people coming to our stand looking a little bit worried, like frowning. And I like to say that it's similar to screen printing, because that's something that most of you are probably familiar with. But instead of screen printing with traditional inks, we use specialized inks. We use inks with silver particles or with carbon so that they're conductive and they can actually create a circuit. And we print these conductive materials using screen printing meshes on substrates like thin TPU films, as you can see here. So the screen printing process itself is rather similar. Of course, it's computerized because you need to have a very precise placement of the different layers of your circuit. The meshes that we're using are different. They are way more fine because you need a very high resolution if you want to print very thin lines and tracks that, of course, aren't allowed to connect, because if they touch each other, if your ink kind of flows and lines are touching each other, you'll immediately have a short circuit. Goodbye, conductive layer. But comparatively, it's very much the same process. So I'll show you a little bit of a video where you can see how we go from design to printing and then to lamination. So in the design process, we have our engineers that, based on the user requirements, start designing a circuit, taking into account the different inks that we'll be using. We develop the screens that are built up from different layers. And with these screens, we print different materials on top of each other on a flexible substrate. So this is one of our printers. We use conductive inks and work with companies that are material suppliers like DuPont, Henkel. Especially for textiles, they develop stretchable inks, so these inks can actually stretch and remain conductive. And after this printing process, we laser cut our films, these TPU, these thermoplastic polyurethane films. We laser cut them out, we place them on the textile, and this goes into a heat press. So as you can see, these are processes, techniques, tools that are already used widely in the industry. And this is why I think printed electronics can really help facilitate making the step towards mass production. Basically, you can think of it as a trim that you can add to any kind of textile. Another big part of the work that I do at Hulst Center is about characterizing materials and doing testing. We do a lot of tensile testing on the fabrics that we've printed with. We do a lot of wash testing, wear testing, obviously, to validate that these materials last for a long time. So like I said, the heat bonding process, you all know these machines. This is what we typically use. So it's not so far-fetched from what you already work with. So what are the benefits of printed electronics? Because there's many ways you can create a smart textile. Obviously, you can take a cone of conductive yarn, you can start weaving, you can do embroidery, you can knit sensors. But what's so interesting about printed electronics is that they are, first of all, ultra-thin. We're talking about very thin TPU foils that hardly interfere with the material properties of the textile. They're flexible and formable, so obviously they can accommodate the body and the movement of the body. They're stretchable, even up to 50%. I'll show you later a project where that was really important. They're biocompatible. All the inks that we're using are used also in medical-grade products, so the requirements are really high. And we have a customizable design. Like I said, if you think about it as a trim, you can really customize your own print, your own pattern that is also functioning as a circuit. So the materials that we're working with are flexible TPU substrates. You can come over next door and feel them and see them up close. And often we need to combine them with rigid components. So this is where a lot of knowledge comes in. We use machines that are known in the electrical engineering industry, where we take small components like chips or LEDs or transistors, and we place them very precisely on these printed circuits. And we use a glue, conductive glue, that cures at a certain temperature. So this is how we create hybrid systems, like the one above, with a small LED, or with a chip here below. And this printing process, as you could see in the video, there's many screen printing screens that you need for it, is very much layered. So all the active layers are printed on top of each other. Sometimes we print non-conductive dielectric layers in between, so that layers are separated and not touching each other. And obviously, not just the print is layered, but also the whole assembly process, for example, of this health patch, is also very much layered, depending on the fabrics that you want to choose, the way that you encapsulate, the way that you protect your circuitry. Another interesting feature, especially when you think about upscaling this technology, is that it's printed roll-to-roll. So like newspapers, basically, these electronics are printed on a long roll and then can be laser cut and be assembled within a manufacturing line. So this example here is actually a flexible OLED printed roll. So what can we print? We can basically print all kinds of things. We can print things like pressure sensors, we can print temperature sensors, we can print all kinds of electrodes for ECG, for heart rate monitoring, or for respiration monitoring. Of course, we print all the tracks that connect these different sensors. We can print strain sensors, flex sensors, and like I said, embedding other rigid components onto it is also possible. So that makes it a very diverse system, and we can combine different inputs and outputs. At the moment, we're, for example, experimenting with connecting our printed electronics with vibration motors, so that we can also have actuating properties and communicate to the body in a very intuitive way. So to give you an example of one of these sensors, this is a pressure sensing insole that we developed. So you see a whole array of these sensors integrated in this shoe insole, and it gives a very high definition image of the gait of someone walking on this shoe. So this could be very interesting for sportswear, for running, for example, but also for medical applications. So some of these ideas are, of course, transferred to physicians who are looking into the possibility of using this for people with Parkinson, for example. So there's a lot of different value in different markets to be found, and that's what makes it very interesting. So it's not so much only about the technology, it's also about the use case, the context of the wearer, that needs to be considered right from the start. And what I try to always emphasize in my talks, so as a designer, I am working in a research center surrounded by a lot of engineers, a lot of smart people, which is great fun. But at the same time, there's also a lot of technology focus. And I try to warn for that, because I think in the end, it has to be engaging, it has to be a holistic approach where the textile, the garment, the fit, the user, and the context are really embedded. And what I'd like to look at is the actual aesthetics of technology, especially when we're talking about fashion, when we're talking about our everyday clothes. We need to feel comfortable wearing it. And the technology is not only something that brings functionality, but it's also, if you look at these solar cells, for example, it really creates a different print, a different patterning on a garment. And that's what you can play around with. So as long as you take that as a starting point, you can really bring it to a different level. So I'd like to tell you a little bit more about Hall Center, because I think most of you are not very familiar with it. I'm quite excited to have brought the research center here, because normally Hall Center presents itself at IDTech X, at LOPEC, at the Consumer Electronics Show in Las Vegas, all technology and consumer electronics fairs. And I think it's very important for these technologies to be visible for a textile design audience. So Whole Center, like I said, is a research center based in Eindhoven. It's the high-tech campus. A lot of people are comparing it with Silicon Valley because it's been called the smartest square kilometer of Europe. Very nice place to be working at. It's very green, as you can see. If I look out my window, I actually see cows and sheep walking by. It's quite funny. So we have our offices there, but we also have our laboratory, high-tech facilities like clean rooms, and a lot of measuring equipment, obviously, to characterize what we do. This is a little bit of an impression of how many people are working in Whole Center. We have a very international staff. We're closely affiliated also with universities and other knowledge institutes. We work very closely with industry, our industry partners and clients, and they basically cover the whole value chain. And this is one of my ambitions also for Smart Textiles, to really have the whole value chain from yarn manufacturers to textile manufacturers to fashion brands to apparel manufacturers united and to be connected with one another and to share research. Because the way that we work in Whole Center is in two ways. We have our open innovation programs that we're very known for, because it's quite revolutionary. We have big brands, big companies, material suppliers, all working together in open innovation groups. They all share an interest in a specific topic. And we put them together and we do the research for them, with them. And they share the knowledge. And obviously, in the market, they are competitors, but in this respect, they actually build on each other's skills because they can all benefit from the fact that they've learned something new. And I think this is also very necessary within the textile and garment industry in order to get smart textiles to the next level. Because everyone needs to be lined up in order to support each other to get a product to the market and to be able to communicate about it also in the same way. So within Whole Center, we have two main focus areas. The first one is health patches. So here on the right, you see a product that we developed with Philips. These patches are used for telemonitoring. They measure vital signs continuously for almost 2 weeks. So you can look at them as an electronic plaster that is stuck onto the skin with an adhesive. You can even shower with it. You can, of course, wear your clothes on top of it. And, of course, it's biocompatible so that it doesn't create any irritation. On the other hand, we have smart clothing. And obviously, since there's such high requirements within the medical space, we have a lot of knowledge that's being developed there that we take into the smart garment domain. And I wanted to start out with a project that's not really a health patch, but it's also not really a garment. This is quite a special project for a startup, a Dutch startup, Bambi Medical. And they actually wanted to create a product for prenatal baby monitoring. So these early-born babies, obviously they are very small and fragile, and they need to be monitored very closely. But at the same time, you don't want to wire them up the whole time. You want also the mother and the father to have very close interaction with them and hold them close to their own skin. So we developed a little belt, basically, that has tiny electrodes integrated that continuously measure vital signs. And this is actually the project where we wanted to reach 50% stretch, because we're dealing with a very tiny circumference around this baby's body that needed to be stretched a lot and needed to stay comfortable, and of course also be very biocompatible. Then another project that I did last year, it's also on show next door. This is a company called NearX, a US-based startup that wanted to create a light therapy device. So together with a physician from Massachusetts General Hospital in Boston, they came up with the idea to develop a headband with infrared LEDs. And this infrared light has been studied and is known for reducing symptoms of stress and anxiety. But obviously, in a medical context, when this is being researched, they're using big, bulky lamps that are put on patients' foreheads in this case, strapped with some elastic around it. So it's very invasive. It's not comfortable at all. It's not very accessible also. You need to go to the hospital all the time. And with this headband, this kind of treatment can actually be done from home. Can be even a wellness product for everyday use. So there's different modules, as you can see, different LED modules integrated that shine into the forehead and that cause a reaction into the tissue. There's also a heart rate sensor integrated, and people can communicate with the headband using a smartphone, so they can select different programs that they want to put on. So what's been very challenging in this particular project is that since it's a headband, obviously it needs to be small. It cannot be very heavy. It needs to be very stretchable. It needs to be very comfortable. It's driving some LEDs. So at the same time, we needed a relatively large battery that still needed to sit comfortably on the head. And yeah, so with that challenge, I think this is quite a big achievement for this company. And they currently, they just rounded off a successful Indiegogo campaign, so they're onto producing this headband at the moment. And we've helped them also to transfer the technology to mass manufacturing partners, because that's not something that we typically do. We focus on the R&D, and then we translate these products into mass manufacturing processes. So I'll show you a little bit of the video.
And stress less. This is NearX, a scientific remedy to recharge your mind. Beneath the surface, NearX has 6 LED modules designed to shine the specific wavelengths of near-infrared light that naturally increase cellular energy in the brain's emotional and cognitive centers. More energy in the brain boosts productivity and lifts mood.
I want to cut it there. Another project that we've worked on together with Marina Toeters, who's a famous wearable technology designer in the Netherlands, is Closedloop, smart at leisure fashion. And what's interesting about this project is that we took sustainability as a starting point in the design process. Working, of course, with printed electronics, we also have to consider how we deal with the end of life of the product. And how can these electronics be consciously separated and recycled? So this garment, which is also on show here at the fair, is a vital sign monitoring garment. There are 4 electrodes integrated in it, using a very lightweight mesh fabric. So it also shows the kind of like materials that you can combine it with. And 2 of these electrodes are monitoring ECG, so heart rate signals. And the other 2 electrodes are measuring bioimpedance. And with bioimpedance, we can measure the breathing rate and the breathing depth. So altogether, we are actually able to say something also about someone's stress levels. So this is a kind of wellness and sports garment. And what we've done in this process is that, so we first will go through a lamination process, but afterwards we've looked at how can we delaminate, how can we remove, again, these printed electronics from a textile. So that has given us a lot of knowledge, and this is something that we're now also expanding into other projects.
Intelligent fashion, containing technology that can measure your health and is still sustainable. My shirt keeps track of my heartbeat and respiration, so I can be more effective. I know there is a lot of technology in there, but I don't feel it. The sensors are seamlessly laminated onto the fabric. It's very comfortable. It's beneficial to wear them on a daily basis because my clothes check my well-being and stress level. The lease and recycle system is a closed loop. I don't have to worry about what to do when the garment is worn out. The technology will be delaminated from the shirt and parts will be recycled. It sounds like a dream of the future, but it's right here and we are wearing it.
And so what's being suggested in this video, what I think is very interesting, is that we can also start thinking of different business models. Instead of continuously selling people new products, we can actually start thinking in terms of services. So such a garment might be something you lease as a customer, and the data, but also maybe any updates or upgrades, are provided by the apparel, the fashion brand. And at the end of the life, it's actually being returned to them so that they can take care of separating and recycling the materials, but also offering you maybe a new type of garment. So this is one of our latest projects. We've developed it last year together with Maxime Dasse, who's standing next door in our lab. She's a student from the Industrial Design Department in Eindhoven at the University of Technology. And she's done her final bachelor project together with us in Whole Center. We like to collaborate a lot with academia, like I said, and bringing young people. So this project is called Mesa. And Mesa is a sweater that's centered around haptic technology. So Maxime, for the start of her project, did a lot of research into haptics. She tested out a lot of vibration patterns and different materials on her own body, but also on the body of her test users that were testing. And eventually she came up with the concept to create a garment that could help people with regulating their stress. So it's particularly suited to the everyday. That's why we wanted it to be a casual, everyday type of sweater. And the electronics are seamlessly and invisibly integrated. So with this sweater and with the app that comes with it, you can actually set certain moments during your day where you want to create a moment for yourself. You can activate the garment by actually touching your side ribs. So there's an opening on the side where you can actually put your arms in, because touching your ribs and feeling them expand is actually known for creating a calming effect on the mind. Then on the spine, along the spine, there is 5 vibration motors integrated that are programmed to move into a calming breath exercise. So basically you feel a vibration along your spine going up and down, and you're basically invited by the sweater to adjust your own breathing rhythm to the rhythm that the sweater gives you. At the same time, your own breathing rhythm is also being monitored so that these 2 rhythms are not too far off, because otherwise it might be very stressful if you're breathing already really high and then you suddenly need to breathe very low and deep. So this is all being combined with one another. So at the moment, like I already said before, we're looking into how printed electronics and haptic technology can be further moved forward. And this, I think, is a very good example case of something that speaks to the body very intuitively, and that is not so much centered around numbers and graphs, like the typical wearable devices that we find on the market nowadays. So this all sounds very nice and maybe very easy, straightforward, or if you look at the finished products, you're like, okay, cool, but what's going on behind it? And I have to be honest, it's not easy. It's actually quite hard. And why is it hard? Well, there's different reasons for that. And I think one of them is that typically people underestimate what it takes. So they are very interested in creating something innovative, in having a product that offers a new type of user experience. But they forget that it's a whole platform that needs to be created. So, for example, in this case, this was a project that we did with one of the largest apparel manufacturers in Southeast Asia. So it's an illuminative running shirt. And here we're dealing with lights. So LEDs, they have been on the market and in the smart textile space for a long time. And I have to say that's pretty straightforward. Also in terms of the system, in terms of the platform, you put some LEDs in the garment and you can decide to put them on and off. Maybe you can have different settings to it. Maybe you can change the color. But you could say, in this case, that's about it. But if you think about the ECG, the vital sign monitoring garment, it's not just the printed electronics and the integration of the electronics in the garment. It's also the hardware that comes with it. It's the app that needs to be connected to it. And also, as a brand putting this out on the market, you have to take into account that you need to do customer service, that you actually need maybe a few people that are dedicated to this app development and that are constantly going to create new content for it. It's not something you can simply launch and sell and then move on to the next project. But at the same time, that's also the strength. Because once you have this platform created, once you have done your first project, you can easily expand it and build new features, new functionalities, new experiential qualities into it. And since the process, this screen printing lamination process, is then already rolled out, it doesn't take much more to then create something new with it. And I really believe that the harder, the more rewarding, the more interesting your product eventually will be. So this, for example, took us a long time to develop, but it's quite interesting how we've been able to create this super high resolution, highly flexible LED display. And what I think is most fun about my job is that I'm doing something new every day, basically. And most of the time, I'm even doing something that I don't even know how exactly I need to do it, but I take my intuition and my experiences from the past, and we take it from there. So I'd like to share with you some of my experiences from practice. Basically, these are some tips, I would say. And the first one is think beyond functionality. A lot of people also in the last days, they come to the booth and they're very much focused on the technology, obviously, because that's also what we're presenting. And it's a lot about what can this do, what can that do, and I want to have a product with this. But the best approach is to look at the whole scenario, the whole garment. Not just the technology, but also the textile, every detail of your garment, every design feature, and consider the whole way of interacting, of experiencing that garment, not just in the very moment where the technology is being used, but throughout the whole day. How is someone going to wear this? How is someone going to feel wearing this? I think that's the best starting point. The next one is think big, definitely think big. But I'd also advise you to start small. I recently had a visit from a company from Asia making underwear. And I explained everything, we showed our facilities, and we had a very nice, lively conversation. And then I had to laugh towards the end because I said, so what is it that you're really after? Like, what would you like to do? And they were like, yeah, you know what would be amazing? If we would have underwear that could adapt its color to the skin tone. And then I was like, yeah, that would be amazing. I would love that. Can we play this video? I would love that. And it's possible. It is possible. I mean, we see it in movies. Here we see we call it active camouflage, basically, so that materials are actively adapting to the surroundings. It's been used also in the military, obviously, for very obvious reasons. So I wouldn't say it's not possible, but yeah, you better start a little bit smaller and make your life a little bit easier if you want to enter smart textiles, wearables space. But don't get me wrong, keep thinking big, because you need that dot on the horizon, and I always love speaking to people who have visionary thoughts, so keep it up. So I started my talk speaking about the laboratory and all the work that we do there and the research that we do, but how do we get this into the world? What is still needed? Of course, there are already companies collaborating with us, developing products that are launched in the market, but there's always improvements. One of them definitely is testing. One type of material, one type of combination of printed electronics with a specific, say, a jersey textile does not mean that another material with the same technology will work out exactly the same. That's the complexity that we deal with when it comes to garments. Every garment shapes is different, the weight is different, the amount of stretch is different. So with every product, with every development that we do, we need to do a lot of testing. And when I say testing, it's not just the material and the performance of the material, but it's especially also qualitative user studies. This is something that I've been focused on a lot. So when I would, for example, develop running apparel with lighting embedded so that people could play interactive games at night when they would go running with a team, it's not so much about the functionality of the light itself and how the garment on its own was functioning. To me, it was more about the social interactions and the social dynamic that's changing when you put these garments into the world and people start, dealing with it. Everyone appropriates the technology in their own way. Everyone interprets the technology in their own way. Some people think something is annoying. Others think it's amazing and they think it's very useful. So having that very subjective first-person opinion registered already in a very early stage of your development is super valuable. Because otherwise, you'll be putting a product in the market that no one's really waiting for, maybe. Another thing that we should look at, something I'm really pushing for also, is that we should approach it from a hybrid perspective. I've now given you a lot of information, a lot of insights about printed electronics. But obviously sometimes, with some products, you might want to use weaving, or you might want to combine printed electronics with embroidery. There's so many solutions out there, so don't think too singular about it. Think about integration with many different techniques. It's not like all techniques are suddenly no longer valuable because we now have something to replace it with. I don't believe that. The same goes for 3D printing. It's not like now we can 3D print textiles and all the regular made textiles are suddenly not valuable anymore. So it's always going to be a hybrid. And obviously, sustainability. I think for me, it's of course a very important question that always goes through my mind. It's one of the main things that keeps me awake at night. What we're doing here needs to be, in the end, sustainable. We don't want to put a lot of products in the market that combine materials that can later on no longer be separated or that use up very valuable resources. So the fact that there's research going on into this is very important. There is research going into biodegradable materials. This, for example, is a circuit that's made from polymers that decompose. So when you put this cellulose substrate in a very weak vinegar, like an acid, then it completely disintegrates, and you can reuse some of the materials. And of course, this is happening in the lab still. This is not available yet. I haven't had it in my own hands. But I'm definitely looking out for it and pushing for this. Otherwise, if that weren't the case, then we shouldn't be progressing with this. I can tell you that very honestly. So what's more? I'd like to show you some other things that are possible, just to also inspire you on what's next in the future. Maybe not something that can be made tomorrow, but something to look forward to. So one of the things that gets me really exciting is this idea of shape changing. And this is a good example by MIT's Tangible Media Lab, where they've actually used printed electronics and combined it with materials that are responsive to electrical signals or to heat. So these materials actually fold up and curl in a pre-programmed shape. So yeah, consider this on a garment, and I think you could create very interesting textures and structures that can open up and close. Something similar to this butterfly that actually was developed, or at least launched, only a week ago from the Korea Advanced Institute of Science and Technology. So here they're also using electrical signals that are sent through this, what they call MXene material. And it's activating these butterfly wings in a very organic way, I'd say. Well, they'll continue flying for a while. And another project, it's also a video I'll put on. This is a recent graduation project from Aishas, I have to pronounce it well, Aishas Pimpalkar, Indian designer who just graduated from Royal College in London. And she actually looked at kinetic textiles, kinetic materials that are activated using small servo motors. And she researched all kinds of origami structures and really wanted to create small organisms almost. And I've spoken to her in person, and what I really liked about what she said is that she wanted to create a certain empathy for within these textiles. So she wanted certain behavior, certain shyness, or certain breathing motion to be part of the textiles. And like I said before, when textiles, when garments become alive, when they gain a certain agency, yeah, we will have a very different relationship with them, I think. We will treat them very differently from what we do now, when they are more passive and inert. Another project that was recently launched is this Halo Smart Color. And what's interesting about this, previously I was talking about shape changing. This is actually phase changing. So it's changing the hardness, the composition, the stiffness of the material. And in this case, it's a neck brace that protects athletes from concussion. So, well, they're demonstrating it, for example, for boxing, kickboxing. But obviously, the applications of this and the implications of this could be much wider than only those sports. And it's not only startups like in this case Exos working on it. It's actually also big brands that take up these new materials. This is a sports bra made by Reebok, where also a material that's called a shear thickening fluid. So it hardens on impact. When you touch it, suddenly it becomes much harder. So they've integrated it in this Pure Move bra. So it's already commercially available. And also an active material, you could say. So we're looking ahead a little bit more. Of course, these electronics are getting closer and closer to our body, to our skin. Some of those biodegradable materials that I showed you previously are actually coming from the medical industry, because they're already looking into small, tiny devices that can be implanted. And obviously, the biocompatibility is extremely high, and also the biodegradability of it is very important. So some of those innovations are coming from very diverse domains. Well, and this is something similar, of course, when we have electronic patches. We can also think of electronic skins that are that can be worn for longer periods of time. And then for something else, I wanted to also include this biosequence that's been developed by Elisa Brunato. And of course, normally sequins are made from petroleum-based plastics. And she actually developed a method to create it from bioplastics. And it's based on cellulose that's been extracted from trees. It looks really mesmerizing, I thought. So I'm reaching the end of my presentation. I already mentioned a couple times, we are next door with our Smart Textiles pop-up lab. So I'd like to invite you to come and have a look. We're actually demonstrating the whole process, except, of course, for the printing, because we don't have those machines over here. But what we're creating is a small pouch that we're demonstrating. I have one over here. Inside of it is a small antenna, a near-field communication chip. So it's a device that allows you to wirelessly communicate with, for example, a smartphone. At least that's what we're showing. So there's a small circuit on it, an antenna that creates a magnetic field that interacts with your phone. There's a couple tiny LEDs on it. You won't see them from this distance. And tiny chips as well. Well, you can maybe see it a little bit on there, but I'd advise you to come and have a look. We're making several of these. If you're interested, we will first test how well you listened to my talk, and then maybe we will give you one if we've made enough, because they're in high demand. But yeah, this is just to demonstrate how it affects the material, what you can actually print, but of course there's many more possibilities. And lastly, I also want to direct you to some interesting publications, some self-promotion. The left one is my own book that's being released in a month from now, with which I'm finishing my PhD. All about the design process of working with technology, how it affects your way of working, but also how we should understand technology in order for us to create engaging products. And on the right side, a book that's been edited by Marina Toeters that gives an amazing overview of everything that's been done in the wearables space since 2000. So we've been working on this for a long time. I wasn't around in 2000 yet, but other people were. So yeah, if you're interested to see what's already out there, to get inspired, I think this is a great publication. And yeah, come check us out later. Thank you for listening.